Hello, good morning. I'm Manuel Castro. I'd like to present to my colleague Gabriel Díaz. He's Associate Professor of the Spanish University for Distance Education, Universidad Nacional de Educación a Distancia, and we are now recording a new version of the webinar of the IOE-EQ, Internet of Energy, Education and Qualification, that the other day we cannot record in because there was some troubles with the sound. I'm so sorry about that, and we will do it today. This webinar is produced inside the IOE-EQ European project and with the collaboration of UNED, of the Spanish Society of Education, of the IEEE Education Society, and with the IEEE Spanish section. It's my pleasure to present you my colleague Gabriel Díaz, and here you have his voice.
We are going to talk about some aspects of cybersecurity in Internet of Energy. Here you have the contents of the presentation. First, we talk about general introduction to the problem. We are going to put some context. Then we will see an introduction to the security in smart grid. Afterwards, we are going to see some statistics and some types of vulnerabilities in this kind of cyber attacks. And finally, we will talk of security in some specific areas of smart grid as the smart meters in the customer area or the smart renewable energy environments for the solar plants. Well, if you try to see the current situation of the safety analysis and the security analysis in the electrical sector, you can see that now ICT, information and communication technologies in the electricity grid is a fact. But the problem is that the focus nowadays is put on energy efficiency in delivery and management guarantee, but the focus is not put on security. The new elements of control and automation we have introduced in smart grid with this digitalization are not taking into account the different kind of cyber threats arising from the exposure to the TCP/IP protocols and specifically to the internet. This is, This is what we call the IT versus OT war, but it's not really a war. It's the result of introducing all the information technology and ICT technologies in the operation technology part. This is leading to a number of different cyber attacks on the infrastructure and is provoking erroneous decisions. If we go specifically to the smart grid, you can think of a smart grid, you can imagine the smart grid as this network here. Of course, it's only an approach, but here you can see all the different plants with the different management systems, the network management systems or the energy management system, all the parts related with invoicing and related with the users. And all these pieces in the network are connected by only a communication network. This communication network allow many different and interesting things. For example, obtaining data from the entire network. It allows the dynamic optimization for maintenance operations and electrical system planning. It allows smart meters and the facility the easy situation of controlling all the billing, and it is mediated, is managed by many different ICS or industrial control systems and specifically SCADA systems in the network. All these things are really connected, or of course the help for all these situations. All these things are connected by a bidirectional communication, or we can say a full duplex communication in only one network. And this, of course, a great enhancement to the whole situation. We can say that we have a network that is distributed with intelligent transmission and interactive. So the smart grid is much more complex much more interactive, intelligent, but of course, this is mediated thanks to the TCP/IP protocols, and TCP/IP protocols, as in any other sector in the industry, are related also with vulnerabilities. So we can finish this part, this context part, talking about the security and safety globally. Globally speaking, we can say we have a number of challenges and a number of vulnerabilities related with four factors: physical, human behavior, political factors, and cybernetics or cyberphysical, as you want to name it. Physical challenges are related with climate disasters and natural disasters. Human behavior are related, as always, because humans are the weakest part of the chain of security. Human behavior are related with errors and with lapses. Political challenges, and vulnerabilities with regulatory policies. And we have introduced now cyber-physical, cybersecurity problems related with intrusions and security. And I would like to say that all these vulnerabilities, all the vulnerabilities in this part are closely related with, for example, the human behavior part. So we have all these challenges, all these vulnerabilities. If we see some statistics, we can see, for example, a figure related with the country's objective of cybercrime, but it's not very important for me now because, okay, if you see the graph, United States is the most attacked, but this is a partial part of the situation because, well, we don't have here, for example, Russia of Ukraine. For me, the most important part, the figure I want you to see in detail is this part, the percentage of cyber attacks by sectors. And here you can see all the critical infrastructure sectors, as for example, communication or water, transportation, nuclear, public health. But the most attacked part, the most important part is clearly on the energy sector. So we are talking about a big problem for all these industrial control system situations, specifically for the energy sector, and specifically for the smart grid. In the smart grid, finally, we are talking about some different threats as thieves or cyber attacks in general, terrorism, natural disasters. Terrorism are, this case, mediated by physical factors, but also by cyber attacks. Or the consequences of these threats and challenges are related with human danger, with chaos energy market, with, of course, damaged consumer devices, system status display errors, failures in smart grid IT and infrastructures, are even, and we have had cases, and even blackouts, small blackouts and large cuts. Maybe the most vulnerable system today is the smart measurement system, with all the problems related to that. And do we have a solution method? Well, the good news is we have solution methods. The bad news is we have solution methods. Here you have only one of the methods related with a framework called Security-Oriented Cyber-Physical State Estimation, or SCPSE, that it identifies or helps to identify the committed costs of the smart grid, and helps also to modify a set of measures through the network of system sensors. If we go to the energy systems and plants, we must realize that any energy system or plant is an industrial control system, and all the industrial control systems now are ICT-based managed. Okay, we say that the systems are connected to the internet and the cloud. That is a little bit redundant, because if you think of the cloud, you are talking of the internet, where we are going to have problems related with data collection in status electric chain sensors, or the energy volume of wind, solar, or nuclear, temperature and position panels and propellers, and in general, the perimeter security status. We have recommendations by a number of standards, depending on the sector we analyze on the smart grid. And again, we have a number of standards, as, for example, this one. And all the requirements, all the security requirements are more or less related with a combination of all these things. The authentication of devices, of the authentication of users, or even of processes, authorization, access control. This is what we call in IT the AAA problem, the authentication, authorization, and access control. But we have requirements also related with integrity, with no redemptions, and even one of the most important today, the prevention of denial of service, because the denial of service attacks are targeting the availability part of the smart grid. So, for example, we can talk of a number of attacks. Here you have 3 slides included from a book on industrial control system security. And for me, the relevant part of the table, here you have only a part of the table, is relating the possible target of the attack with possible attack vectors. Attack vectors are the tools, the media, the process you use, not the process, the tools and the media specifically you use for attacking the target. For each of the vectors, you are going to have a number of methods to attack. And of course, these attacks are related with possible consequences. For example, if you see here, you can say, okay, possible target is an application server. How do we attack an application server? We can attack an application server through a remote user access with interactive sessions, or through a business application integration communication channel, or inside the plant or the system in the network, in the plant network, or even by using a software vendor support portal. For all these vectors, you are going to use one of these methods: the exploitation of unpatched application, installation of malware via a vendor software that is not validated, remote access via interactive via interactive accounts, or a database injection, or even some insecure implementation of communication protocols. And possible consequences come from authorized access to additional ICS assets, or sensitive leakage, or sensitive information or confidential information leakage, or credential leakage for the part of control, or even a plan upset or a plan shutdown. Here you have another part of this table. For example, if we go to attack a condition monitoring system, you can attack this condition monitoring system through a subcontractor laptop, or through the process of maintenance remote access, or again through the network, the plant, in this case related with maintenance, or a software vendor support portal. You can use many different methods. Again, exploitation of unpatched application, installation of malware, network access via insecure access points, even through a VPN, because many people say, okay, we have a VPN, we are safe. This is not true. A VPN can be attacked too, for example, via stolen or compromised subcontractor laptop, or via compromise of maintenance vendor sites. Okay, we have a number of methods, and again, we can have dangerous consequences. And finally, for the third part of this table I have included here, if you attack, that is a typical situation, an engineering workstation, you have different vectors of attacks, from applications to software vendor support. But I want you to remark this USB removable media. Methods related with these vectors, again, exploitation of unpatched application, installation of malware via software, or via this is USB devices, and different and sometimes dramatic consequences. Okay. So when we talk of all these possible and not very good situations, we must take into account very strongly three security, cybersecurity, not only cyber, but cybersecurity key variables that are many times called the CIA triad. Okay, the confidentiality, integrity, availability triad. We must think of confidentiality. Medium relevance in this case is related with the relevance of the problems related with that key variable in a smart grid. Confidentiality is ensure that we have an authorized disclosure of customer information. We have integrity problems. Integrity is related with that the data is not modified without authorization. The data has an authenticated data source, and also and the associated time mark is known and is authentic. And maybe the most dangerous one today is the availability key variable. Availability with a high relevance too is related with the access time to the data or the access time to the information systems that we must try to ensure that is correct and that is not interrupted. Now we go then to some specific aspects. First of these aspects is related with the customer areas or the smart meters and the AMI part of the infrastructure. The AMI is the advanced metering infrastructures. And as I'm not sure that all of you know some terms, we are going to define three terms: HANs, BANs, and NANs. HAN or HAM, home area network. HAN, home area network, is related with all the devices connected by the network in a home, and of course managed through the network. Okay, this is HAN. We have also BAN. BAN is building area network and is related with all the devices connected in the network but of a building. And finally, we have NAN, or neighborhood area networks, and these networks are networks composed by different buildings and home area networks. So if we go to these HANs, NAN, and BANs, and we try to see the security aspects here, we must take into account a number of things. We must take into account that we are using technically simple devices with very limited security layers. We must take into account also that for all the networking, we are almost 100% based on wireless communications. Wireless communications are difficult to secure in a proper way for all these things. Of course, we are going to use cryptography, or we must use cryptography. But if we use cryptography, we are going to we must have a difficult management target, that is managing millions of keys related with the devices in a context where we don't have a common standard agreement, okay, then with different protocols. And the problem is also all these protocols, the different protocols are related with the fact that the different vendors and organizations are not really following the same kind of standards, so we have a problem of access. This leads us to a number of problems related with confidentiality for the information that the devices are exchanging. Some devices, well, the most important devices here related, of course, with smart meters and with home automation devices. We have problems also related with data integrity. and we have problems related with availability. Okay, although in this case availability maybe is not so big problem because we are not going to need a constant real-time monitoring. Okay, if we see more in detail some of the attacks, we can see here data injection attacks. In this case, the attack is directed to handling the data exchanges from smart meter source feedback to control all the system and the electricity price. How attacking hardware or communication links, and Stuxnet is maybe the most famous attack of this kind, related with some big problems related with centrifugers on nuclear plants on Iran. I think 10 years ago, more or less. And the most common attacks here the most common data injection attacks are related with alter the network estimation data, the voltage quantities and the phase angles of each of buses. We have another typical attack here is the time synchronization attacks. In this case, we try to, or the attacker tries to alter the PMUs. The PMU is the phasor measurement units, and the alteration is related with how to measure, how not to measure correctly voltage and current phases by manipulating the time reference of the phases. And this results in a wrong display system status and a number of triggered errors, as for example, the activation of false alarms. We have also availability attacks. DOS is the acronym for denial of service. Availability attacks, and especially distributed DOS, distributed denial of service attacks, because distributed denial of service attacks are stronger and much more difficult to stop. These attacks are related with temporary block the key signals, resulting in alteration of times in the observability of the network status and provoking a number of errors related with delays in access to status data and delays in actions to correct the state of the system. Okay, availability problems. We have also dynamic system attacks, as for example, a reply attack. A reply attack consists in replaying with commands try to insert erroneous data, and dynamic data injection attacks that come from a previous study of the network model, and again inserting the erroneous data, and this has provoked in some situations very serious, very serious problems, leading to even to system collapses. Okay, we have related with the smart meters. I have said before, we have what we call AMI. AMI is the acronym for Advanced Metering Infrastructure, and we have a number of standards and numbers of frameworks for trying to secure this AMI. We have put here one of them, but you have many, or you have at least more than one. And in this case, and I would say in any case, you are trying seriously to affront the security problem. But okay, in this AMI architecture security developed by SG and NIST, specifically NIST. NIST, you know, is the National Institute of Standards and Technologies of the States. All this architecture security is trying to fight against eavesdropping or non-authorized traffic analysis or EMRF interceptions, more interceptions, reputations. Very important, at least for me, the investigation by personnel, because we are having attacks related with the non-good use of social networks by the personnel of the plants, leading to bypass controls, authorization violation, physical intrusion, man-in-the-middle attacks, integrity violations, thefts, replay attacks again, We have also the possibility to have problems related with malware installed in the software of our devices. And malware, malware is malicious software, so we have many different examples as virus, or worms, Trojan horses, trapdoors. We are going to have problems related with resource extractions and many different kind of typical security problems in IT that now are not problems only for IT but also for OT, and as a consequence for the smart grid. The last situation I want you to see is related with the attacks to photovoltaic plants. And again, we must begin with how to see the problems related with the CIA triad: confidentiality, integrity, and availability. Again, here we can have an intruder spying communications, accessing confidential information, and again, it's a medium relevance problem, but it's a problem. We have integrity problems with high relevance or very high relevance related with attacks as the many different kind of man-in-the-middle attacks, when you put between one node and another node a third kind of ghost node to intercept the data and change the data. These are the man-in-the-middle attacks. We have also replay attacks or passive espionage, that is sniffing or seeing the traffic through the network. And of course, you have very high relevant problems related with availability. Again, with denial of service that suspends the communication or provokes communication delays or provokes resource extractions or desynchronization. Maybe the most worrying attacks here are availability, because they are targeting the continuity of the plan, the continuity of services, the continuity of the data access time. Specific vulnerabilities here are related with also with monitoring. Okay, monitoring inverter parameters that can be followed locally or remotely, and remote monitoring through Wi-Fi or Bluetooth and another wireless protocols that can be attacked also compromising the data inverter. Because we have the management of the communication routes for the safety of the plant to be up. The data must be safe and reliable, and also because the inverters are converting direct current to alternative current. As we will see now, they have at least 2 clear points of vulnerability. And also with a control part of the plant related with the different kind of portals for the integral management software in the photovoltaic plants. And these control systems, of course, can be also attacked to manipulate inverters. Here you have some of the most typical problems. For example, on the physical layer, we can say we have default passwords, because all the inverters come with factory passwords. All the different manufacturers are delivering the inverters with factory passwords. The passwords can be accessible from the internet or through the manufacturer's documentation. I remember, I don't know what's the name now, but 2 years ago, you can see an internet a website called what'sthepassword.com. What'sthepassword.com has had a very big list of passwords related with any kind of devices. So all you must do is go into the website, search the manufacturers, search the specific device, and search the specific default password. So one of the problems you must take into account is to change this factory password. Another closely related problem is because it's physical handling also, is related with the physical security measure as perimeter cameras, lights, and so on. But we have no detection of physical manipulations of inverters, because all the inverters we are working with lack pre-installed hardware or software or firmware that alert us for physical manipulation detection. We have Wi-Fi networks. Inverters are connected via Wi-Fi at home or in business, and we can have attacks related with hacking these Wi-Fi networks that leads to control the inverter, for example. We have problems related with the integrated circuits we are using. Now we have two specific and very strong vulnerabilities as expected on meltdown in our microprocessors. And these vulnerabilities allow access to memory areas restricted to operation. And this allows us to obtain keys and obtain data. And we are talking at the very, I don't know how to say, hard first level, the integrated circuit. These problems are related also with the access of networks that must be restricted but are unrestricted, the access to the inverter from another computer connected to the same network. And of course, we have many problems related with remote code execution of code, of arbitrary code that produces denial of service attacks to the plant. To finish, the problem is, do we have strategies for try to cyber secure smart grid? The answer is yes, but it's not only yes. The situation is we have different strategies. We have different groups, public and private, working for building different kind of strategies. You have here, for example, one public approximation, one public approach that comes from the National Institute of Standards and Technology, Guidelines for Smart Grid Cybersecurity. So you have approximations, you have approaches to try to secure the smart grid. But you must remember that the smart grid, as we have seen, is a complex system, very complex system. So the approach to secure a very complex system is not an easy one. Okay, it's not an easy one. It's a complex approach. So maybe one first idea is try to divide the problem as all these approaches are doing. Okay, so some conclusions. Control and automation elements do not take into account the cyber threats due to the internet and TCP/IP exposure of this. All the functions in the smart grid are in risk: electricity supply and distribution, generation, distribution and measurement equipment, communication between systems and equipment. The cybersecurity of a smart grid city must ensure the integrity, availability, and confidentiality of the managed data. You must take into account the simplicity of devices and wireless communications in hand, NAN, and bands context, and also the key management and the non-complete standards in many communication protocols. The most representative attacks are all these DIAN TSC attacks, and if you must remember only one of the attacks in this presentation are the DOS attacks, the denial of service attacks. We have different approaches related with how to secure the AMI part, the Advanced Metering Infrastructure part. One of them is this developed by NIST, but it's only one. The algorithms and technology of IT part of technology can be used against spying users. The most important attacks in photovoltaic plants are, again, availability attacks, as again the denial of service attacks we have seen. We have risk related also with current inverters. and systems and software of control of plants. We have vulnerabilities related, physical vulnerability related with inverters. We must change by default factory password and things like that. And we must take into account also the possibility of hacking the Wi-Fi networks and using the vulnerabilities in microprocessors. And that's all, okay? So I want to thank you very much. And this time I want you to keep calm and stay home. Thank you very much.
Thank you very much, Gabi. It was a really good connection today. Congratulations. And the other day we have only one question. I did it. The question was about the connections and the safety in the case of the people that is moving around the electromagnetic area and so on there. For example, if you put some people with the cars loading the batteries in the ground, if there is feasible to have this kind of security there to try to avoid it, or should be feasible to do it?
But you are talking of cybersecurity
Yes, for the cybersecurity in this case. For example, if some people can remotely upgrade or upscale the level of the voltage or the level of the current, or they can put out or something like that there.
Yes, they can. It depends on the security of the communications. You have, for example, here in Spain, we have an institute called INCIBE, Instituto Nacional de Ciberseguridad, or even the CNPIC, the Centro Nacional de Protección de Infraestructuras Críticas. And here you can see a list of vulnerabilities that is updated every day. Every day you have 3 or 4 vulnerabilities, and from time to time you can see in the list this kind of attacks, because the security of the communications many times is clear security, so you don't have even a VPN, so it's possible. It's possible.
Yes, no, the thing is that not only the things that we have in mind, for example, the central utilities or something like that used to be really well protected, but any place in the chain of the energy environment should be feasible for an attack there.
It depends on the kind of
Yes.
attack. If you for example, if you think of Stuxnet, the first thing attackers do with Stuxnet is downloading by using a USB in some of the devices inside the plant, downloading a software that allow to change the behavior of the centrifuges of the nuclear plant from outside. So it's only a kind of doing a more sophisticated attacks.
Okay, thank you very much then, and thank you for all the things. Thank you for all the people that should be looking for this recording after the conference. Thank you for the project IOE EQ that is co-funded by the Erasmus Plus project program of the European Union, and thank to the UNED, thank to the Spanish chapter of the IEEE Education Society, and thank to the IEEE Spanish section. Thank you, and bye-bye then.
Bye-bye.